Okay, hi and welcome to video notes 9.2, which we're going to talk about multiplying and factoring polynomials and their relationship between multiplying, which are multiplying and factoring, and going back and forth between them. So we've done multiplication of polynomials plenty of times, but let's review. As always, down here in the notes, here's a couple examples. Make sure you pause, write those down, watch what I'm doing. Obviously, the arrows here mean distributive property, meaning that I'm distributing this 4x by multiplying it to every term inside. But let's do one just to kind of remind us what it looks like. So we've got a monomial here, or a term, 6x, which we're going to multiply to the polynomial of 2x cubed plus 7x. And we're going to distribute that by showing these arrows. That just shows our work that we're multiplying it to both terms there, both parts of the polynomial. So remember, when we multiply here, when we're last section of notes, we talked about adding. When we multiply two terms or two monomials together, the coefficients, right, add, and multiply, let's get that right. The coefficients multiply and the exponents add. So let's remember that rule. That's going to be really essential for today. All right, so when we do this, we're going to go ahead and multiply these two together. So we're going to multiply these coefficients, 6 and 2, which is going to give us 12, and x, which is to the first power, remember, x to the first power times x cubed is going to be 1 plus 3, or x to the fourth. We're going to duplicate that again. 6 times 7 is going to be 42. Don't forget to carry your sign down. They're both positive, so it'll be a positive result. So that's going to be 42 for our coefficients, and x to the first plus another x to the first, so we're going to end up with x squared. Okay, so that's what that would be multiplied out. Again, pause, check those out. Just to review, multiplying terms, we're going to multiply coefficients and add exponents. Get that down, memorize that, and remember, these should be in standard form when you're done. So just to kind of peek back over here, if you had a higher degree somewhere in this term or those monomials, right? If this was a higher exponent here, you'd have to move that to the left. It will not always come out in standard form, even though all of these examples did. Don't count on that. All right, so let's move down here. And what we're really going to talk about today, now that we've kind of refreshed what multiplication is that we're going to talk about factoring. It's really kind of our goal today. And we're going to do the simplest form of factoring, which is going to be GCF factoring. And we're going to start small with some numbers and work our way up all the way to factoring two polynomials, a monomial and a polynomial of multiple terms. Okay? Multiplication and factoring are quite literally the opposite of each other. They undo each other or do each other, however you'd like to say that. By definition, to factor means that you're going to break up some number, and eventually polynomials here, that can be multiplied together into the original number. So we're going to break it up into the parts that we would have used to multiplying it down. So again, we're essentially undoing multiplication. All right, so let's take a peek over here. Again, just to kind of get this point across, multiplying, if we're multiplying, we're going to go get rid of factoring, and if we're factoring, we're going back and we can multiply. So we're undoing each other. So when you multiply something, you're now able to factor it, and if you factor something, you're going to be able to multiply it back together. How do we do that? Well, you either multiply or use a distributive property in factored form, and that's going to take you back to a multiplied form, and then you can take that polynomial or number or whatever we're dealing with, and you can GCF it, which is what we're going to learn today, and factor, which we're going to learn in the next coming notes. So these are the new things. These, you know, right? This is knowledge that you already have here. All right, so let's go over here and try it with some numbers. Here are our numbers, and we're going to bring up something that you haven't done in a while, but you should be familiar with from way back in the day, which is, well, I'll scoot back over here now, is a factor tree, right? We're going to take a number and break it up into all of its factors. Really, our goal is to get down here into prime factors. And in doing this, what we're looking for is we're looking for the same factors between a pair of numbers or more, okay? Because we're starting with numbers. So if we look here, 4, and we're just going to start with a single number, we're just going to factor it, right? Factor tree. Looks like a tree. That's what that little triangle, kind of like my Christmas tree I drew there. So we're going to go ahead and take 4 and break it up in all the possible numbers that multiply to make 4. Again, prime numbers that make 4. So we're going to break that up into 2 times 2. Again, under multiplication, right? 15 is going to break up into 3 and 5. 24 is going to break up into 6 and 4, but that's not our prime numbers because 6 and 4 can also break up again. So if we take 3 times 2 times 2 times 2, we'll also get to 24. So these are the factors of these numbers. Well, let's see that in a little bit more of a definition. So again, the greatest common factors is 2 or more numbers. That is the largest number that divides each of the following numbers. So that's the greatest common factor. What we found here were just factors. Okay, the greatest common factors, for example, would have been 6 and 4. Well, 3 and 2 are factors. The greatest common factors are 6 and 4. So that's what we're going to be looking for. Are But sometimes to be able to see this, we need to break it all the way down to prime. Okay, so let's jump to the other page. Okay, keeping with that last set of notes on the first page there, we're going to now look at a pair of numbers. We're going to start small and work our way up to polynomials. We're going to look at a pair of numbers, and we're going to see what the greatest common factor is between a pair of numbers. So we're going to do a factor tree on both, and then in doing the factor tree, we're looking for, again, the greatest. Make sure I got my pen marked. We're looking for the greatest. We will break them down to prime, though, to make sure that we have some common factors. That's how you make sure that you have a common factor if you don't see it right away. So in this first example, what I'm explaining then is I'm going to take 8 and just break it up into its factor tree, which is 4 times 2. And we're going to go ahead and break it up into all its prime. And 4 breaks up into 2 times 2. Okay. 12 will break up into 4 times 3. And then we can break that 4 up into 2 times 2. What we're looking for here to get to the greatest common factor are these same factors between both trees. So in this case, the greatest factor, while 2 is common between both of them, 4 is the greatest of those factors. So the GCF between the pair of numbers 8 and 12 happens to be 4. Now, I'm doing these factor trees, and obviously at some point I'm going to stop doing them because we can kind of see what number divides into 8 and 12, and 4 is going to be the largest of those numbers that divides into both pairs. Eventually you'll do this in your head, but right now I'm just drawing out the factor tree so that you can see it. So here's another example. Let's do this one at the end, which is negative 50 and 60. Right off the bat of my top of my head, I know that 10 is probably pretty common in there because they both have a 0. So, but let's break it up and see what it looks like. So if we take negative 50 and break it up into two factors, we're going to break the first two factors that we come up with, which is going to be negative 5 and 10. And then we're going to break 10 up because we know that that has some common factors as well, which is going to be 5 and 2. These are all primes. I'm now done with that one. That's where we say we break it down to primes. We know that we finished that. So let's factor 60. 60 is going to play out pretty much the same way. It's going to be 6 and 10 is going to play out the same way as 5 and 2. Again, we do have common factors of 5 and 2 between these two numbers, but the greatest common factors that are possible are the 10s. So for this particular number then, the GCF, or this particular pair of numbers, the GCF for this is 10. All right, well, let's try that now with something a little bit different. We're going to try to find that greatest common factor of a monomial. Sorry, don't get caught like that, like I did. All right, so we're going to try to do it of a monomial. So here's two monomials. Here's an example of x squared and x cubed. Here's another set of pair of monomials, 4y squared and 2y cubed. And you can see what we're doing here. And go ahead and write those down. Make sure you check them out. But what we'll do is we'll take a factor tree of the coefficients of the monomial, right? But for a monomial like this, or any polynomial or any term, we also have to check what's common between the variables. Now, the variables operate a little different. While we're looking for the numbers that multiply or divide out the largest of them for the coefficients, for the variables, what we're looking at is really y squared means y times y, right? Two y's multiplied together. And y cubed means y times y times y. We're looking for the common number of y's between those variables. Well, the common number is 2. I can have 2 here, and I've got 3 here, so 2 is common there. So the GCF then becomes the common number of the coefficient, 2, and then the common number of variables that is common between them, which is also 2. So we get 2 times our 2y's, which makes 2y squared. So if we took 2y squared, it's divisible in 4y squared, and it's divisible in 2y cubed. That's your GCF, okay? Okay, so let's try that on our own here. We're going to take this number of this monomial of negative 16t to the fifth, and this number 30t squared, and we're going to see if we can break them down. So let's take this 16 here, and we're going to break that up into the first two factors we think of, which is going to be negative 1 and 16. Now, the reason I wanted to pull I guess we didn't have to break it up into negative 1, 16. We could have done a different number. But we're going to break 16 up into 4 times 4, and then eventually we're going to break 4's up into 2 times 2. Okay, so now we've got down to our prime numbers. We know that we factored all the possibilities out. Now, let's take a look at the 30 here. Now, in 30, we're going to break that up into 2 and 15. And then we know that 15 is also going to break up into 3 times 5. Again, we've reached prime numbers, so we know that we can stop. So let's check to see what's common for our coefficients. We can see here that we've got 2 seems to be the largest common factor. Okay, so 2 is going to be our common largest factor for our coefficients. On the variables, though, let's change colors so you can see this out. I've got 5 t's here, so I'm going to scoot over here to the left. So I've got t times t times t times t times t. This one I have 2 t's common, so t times t. So the most common number of t's, or variables, that I can pull out of here is 2. So my GCF then for this one is going to be the 2's that are common for the coefficient, and there's going to be 2 sets of t's, or 2 t's that I can take out, or t squared. So this is the largest number that I can divide, or I'm sorry, polynomial, that I can divide out of these 2 pairs of polynomials. All right, so let's just review that. Let's say it in a little bit different terms so we can see it. What you're really looking to do for GCF of any terms or polynomials, okay, or monomials, sorry, all kind of the same thing, is the largest number divisible by both coefficients. So you're looking at the coefficients and you're trying to find the largest number possible that you can divide out. Additionally, you have to look at the variable and find the largest common number that will be in common of the variables, and that'll become your exponent. So that's really what we're going to do. So let's move into what is a little bit closer to what we'll do in class with this. Everything's kind of prep and leading up to this. So if we come down to this one, I've done both of these examples, so we'll just talk about them. Here's 2, or a pair of monomials, right? And then we did the same thing up above. Again, looking at the largest number that's going to divide into 5 and 10, I can visualize that and see it in my head. The number that's going to divide into both of those is 5. 5 divides into 5, and 5 divides into 10, and that is definitely the largest number. I don't need a factor tree. And then with the v's, I'm going to look at those. I know I've got 5 v's here multiplied together, and I've got 3 here, so the most I can pull out is 3 v's. Okay, so let's look at this with 3 terms in it. Again, now I've got to compare 4, 2, and 6. What number is divisible? And hopefully we get the largest one into 4, 2, and 6. Well, that's easy because we've got a 2 here. So 2 is going to limit what we can do. So 2 is divisible in 4, 2 is divisible by 2, and 6 is divisible by 2. So we're going to pull out a 2. Now the b's, on the other hand, we've got 3 b's possible here, 2 b's possible here, and a single b in this term. So b is divisible in all 3 terms, but just a single b. Okay. Now, here's the next part about this. This is where we're going. Tomorrow is going to be a big factoring day. But right now we're going to get this GCF part down. If we're going to factor polynomials, we really are dividing something out, correct? We're dividing this number out. But what's left over? What's left over after we divide it out? Well, there's going to be a remainder. If we divide 4b cubed by 2b, the 4 and the 2 are going to divide, leaving a 2. And then the b's are going to divide out or subtract out, so it's going to go to b squared. That would be the remainder that would be left over. So if we want to be able to multiply this back out, we have to account for the GCF out front because we divided it out, so we want to show it so it can be multiplied back in or multiplied by distributive property back in. And then we want to write what the leftovers are inside parentheses so that this can be multiplied to them. Okay? That looks a little crazy. Let's try 2. Let's talk about 1 and try 1. So if we look at this here, notice our directions this time is to factor the polynomial and then multiply to check. So we've got an additional direction there. Doesn't ask for the GCF like the other ones did up here. Notice that our directions here, it just says find the GCF. So now we're actually factoring. Okay, so it's a little bit different. It's not identify the GCF, it's identify it, divide it out, show me what's left over. So what does that look like? Well, let's do what we did before. Here's our first monomial. Here's our second monomial, right? And we're going to go ahead and find out what's common between 3t squared and negative 18 that we can divide out. Well, 3 happens to be the only number that's divisible between 3 and 18, so that is our GCF. The reason there's no t's is because 18 doesn't have any t's with it. It has no variable, so there's none in common between them. So the GCF for this pair of monomials is 3. Well, let's divide 3 out of both of those terms and write the remainders right here, okay? So if we take 3t squared divided by t, or divided by 3, the 3's divide out, they turn into 1, and the only thing that's left, the remainder then, is that t squared right here. And if we take negative 18 and divide it by 3, the only thing left is 6. So we write the GCF in front, and then we write the remainders inside some parentheses. Now we're going to multiply to check. And multiply to check, we're going to do the distributive property. So 3 times t squared is 3t squared. 3 times negative 6 is negative 18. These should be the same. We went back and forth. We unmultiplied it. So let's do that with a couple more terms inside of here. So now we've got 3 terms. Let's identify the GCF first. So the GCF for this one, let's look at our numbers first, 6, 12, and 24. What's common between all those and the largest? We could factor tree it, but 6 looks really easily divisible in there. So we're going to go ahead and say that 6 is divisible by 12, 24, and 6 itself. Let's check the m's though. I've got 3 m's here, I've got 2 m's here, and I've got 1 m here. So the most m's that we have in common is 1 m in each term. So I'm going to write 6m as my GCF. So now I'm going to put it in factored form. Okay, so what does that look like? I'm going to put the GCF out front. I'm going to show the parentheses for my multiplication, and now I'm going to write what's left over after I divide this 6m out of each of these terms. 6 divided by 6 is 1, and when I divide the m's out, my degree drops by whatever here is, whatever the exponent is of my GCF. In this case, it's 1, so it's going to go down to m squared. Right? I'm going to retain my sign, because that has to be a negative term. So 12 divided by, or negative 12 divided by 6 is negative 2. And my m's are going to decrease by 1. So I've got 2 m's, it's going to decrease by 1. Again, it's going to be a negative result here because that's negative. 24 divided by 6 is 4. And my m's, 1 minus 1, it gives me to 0, which means it doesn't show up here. So far, so good. Let's multiply it out and make sure that we factored that by GCF correctly. So we're going to distribute. 6m times m squared is 6m. Remember, multiply your coefficients. Coefficient of 1, 6 times 1 is 6. And add your exponents. 1 plus 2 is 3. Now we're going to do it to the next term over. So 6 times negative 2 is negative 12. M to the first and m to the first, we add those, so it's going to be m squared. 6 times negative 4 is negative 24. And then m, and there's no m to multiply, so it'll just stay m. And these are now the same. So multiplying out undoes factoring, and factoring sets you up to multiply. All right, this is where we're going to spend most of our time. Everything else was just to kind of get you to see what we were doing. Right? So by the end of these notes, you should understand what a GCF is. You should understand how to GCF a polynomial, a monomial, and some numbers if we have to do that. And of course, we know that sometimes we need to factor down to prime so we can find our common and make sure that we have all the possible factors. All right, I think that's pretty much everything that we've covered in these notes, and we'll see you in class. Good job.